On the morning of July 25, 1944, a lone, twin-engined aircraft streaked across the skies near Munich, moving at a speed that seemed to defy physics. British pilots of No. 616 Squadron, flying their nimble Spitfires, watched in stunned disbelief. The aircraft had no propellers. It left not a trail of smoke, but a ghostly whisper and thin contrails in its wake. As it effortlessly pulled away from their desperate attempts to intercept, a chilling realization settled over the Allied airmen. The rules of the air war had just changed, irrevocably. This was the Messerschmitt Me-262 Schwalbe, the world's first operational jet fighter. Its appearance in the war's final year was not merely a technological curiosity, it was a harbinger. Though too few and too late to alter the war's ultimate outcome, the debut of the jet fighter in World War II represented a seismic shift, a violent birth that compressed a generation of aeronautical advancement into a few desperate months, forever severing the era of the propeller-driven ace and catapulting aerial warfare into the modern age. This article will explore the critical, complex, and often paradoxical role of jet aircraft in World War II. It will move beyond the simplistic question of who won the jet race to analyze how these revolutionary machines emerged from the crucible of total war, the profound tactical and strategic impacts they had even in their limited deployment, and the lasting legacy they imprinted on global military power, aviation technology, and the very nature of conflict in the dawning Cold War era. Part 1. The Crucible of Necessity, the Theoretical and Wartime Birth of the Jet Engine. The story of World War II fighter jets is not one of a sudden invention in the 1940s. Its roots lie in the theoretical work of pioneering engineers in the preceding decades, men whose visions were only realized when the furnace of global war provided the necessary urgency, resources, and terrifying purpose. The fundamental limitation of the propeller-driven aircraft was clear to these visionaries. As a plane approaches the speed of sound, propeller efficiency plummets due to wave drag and compressibility effects, while the piston engines themselves face insurmountable mechanical and thermal barriers. The piston-engine-propeller combination had, by the late 1930s, approached its thermodynamic and mechanical ceiling, with the most advanced designs like the Rolls-Royce Merlin and the Daimler-Benz DB605 representing a zenith of complex, maintenance-intensive machinery. The jet engine, or gas turbine, offered a revolutionary alternative in elegant simplicity. By compressing incoming air, mixing it with fuel in a combustion chamber, and igniting it to create a high-temperature, high-velocity exhaust stream, it promised not only unprecedented speeds, but smoother power delivery at high altitudes and a potentially more reliable mechanical layout with far fewer moving parts than a piston engine. The concept was not new. Sketches for turbine-based propulsion date back to the early 20th century. However, the material science and precision engineering required to build a functioning, efficient engine were immense hurdles. In Britain, a young Royal Air Force officer, Frank Whittle, patented his design for a turbojet in 1930. For years, he battled official skepticism and a lack of funding, his radical idea seen as a pipe dream by a military establishment invested in incremental propeller development. It was only in 1936, with war clouds gathering, that the Air Ministry finally provided backing for his company, Power Jets Limited. Parallel to this, and in complete secrecy, a young German physicist, Hans von Ohain, working with the enthusiastic support of aircraft designer Ernst Heinkel, developed his own turbojet concept. Heinkel, an innovator frustrated by the conservative Reich Luftwaffe Ministerium, saw the jet as a path to leapfrog competitors. This divergence in early support is telling. In Germany, the embrace of Wunderwaffen, or wonder weapons, as a means to achieve qualitative over quantitative superiority was already part of the military psyche. The RLM, while often bureaucratic, was more willing than its Allied counterparts in the mid-1930s to entertain radical ideas for achieving decisive technical advantage. The result was the Heinkel HE-178, which made the world's first purely jet-powered flight on August 27, 1939, mere days before the invasion of Poland. It was a proof of concept, crude and short-ranged, but it was airborne. Thus, World War II did not create the idea of the jet engine, but it acted as an unparalleled accelerant. The conflict created a desperate environment where existential threats overrode institutional inertia. The massive state-directed mobilization of scientific and industrial resources, a hallmark of total war, provided the funding, manpower, and urgent deadlines that pure research lacked. The jet was born not in a period of peaceful innovation, but in a race for survival and dominance, where the luxury of a decade-long development cycle was replaced by the frantic imperative of months. The war demanded the impossible, and in doing so, made it possible. Part 2. The Contenders. Designs forged by doctrine, industry, and desperation. The jet fighters that clawed their way off drawing boards and into the tumultuous skies of 1944-1945 were not uniform in capability or purpose. They were stark reflections of the strategic positions, industrial philosophies, and levels of desperation of their nations. Germany, the pioneers under siege. Germany fielded the only jet fighters to see significant combat, and its programs were the most varied and in some cases the most radical. The Messerschmitt Me-262 Schwalbe stands as the iconic jet of the war. Aesthetically and aerodynamically, it was a masterpiece. Its swept wings, a feature stumbled upon rather than fully understood initially, but crucial to delaying compressibility effects, sleek fuselage, and twin Junkers JUM-004 turbojets mounted in nostrils under the wings created a silhouette that screamed speed. It could reach 540 miles per hour, over 100 miles per hour faster than the P-51D Mustang, and nearly 150 miles per hour than the latest Spitfires. Its armament of four 30mm Mk-108 cannons was devastating. A short burst could dismember the sturdy B-17 Flying Fortress. Yet, the Messerschmitt Me-262 was a child of crisis, and its story is one of tragically squandered potential. Its development, beginning in 1939, was plagued by delays. Engine reliability was a nightmare. The Jumo 004, while an advanced axial flow design, suffered from a shortage of the heat-resistant nickel and chromium alloys needed for its turbine blades. Engineers were forced to use substitute materials and even introduce hollow blades with crude air cooling, resulting in an engine lifespan of a mere 10 to 25 hours. Throttle movements had to be painstakingly slow to prevent flameouts or catastrophic turbine failures. The most famous impediment was political. In 1943, Adolf Hitler, witnessing a demonstration, infamously demanded the Me-262 be converted into a high-speed bomber, Blitz bomber, to strike back at the Allied invasion forces he knew were coming. This directive, resisted but ultimately obeyed by Messerschmitt and the Luftwaffe, caused a disastrous diversion of resources and delayed the fighter variant's introduction by at least 6 critical months. When it finally entered service with Kommando Novotny in October 1944, it did so into an airspace utterly dominated by Allied fighters, on the backdrop of disintegrating fuel supplies, bomb-cratered runways, and a critical shortage of trained pilots.
The jet was thrown into battle not as a war-winning spearhead, but as a desperate fire brigade.
Beyond the Me-262, Germany's jet and rocket programs displayed a blend of genius and madness. The Arado AR-234 Blitz, the world's first operational jet bomber, performed miraculous high-speed, high-altitude reconnaissance missions that Allied aircraft could not touch, providing the Wehrmacht with its last clear pictures of the Normandy beachhead and other fronts. The Messerschmitt Me-163 Comet, a rocket-powered interceptor, was even more extreme. Taking off from a trolley and climbing to bomber altitude in under 3 minutes, it was a breathtaking, volatile, and ultimately deadly design for its pilots, powered by a hypergolic fuel mix so corrosive it posed as much danger to its user as to the enemy. Britain, the pragmatic defender. Britain's Gloucester Meteor entered squadron service with no 616 Squadron in July 1944, just days after the Me-262's combat debut. In a direct comparison, it was the inferior fighter. Its design was more conservative, with straight wings and bulky centrifugal flow Rolls-Royce Welland engines derived directly from Frank Whittle's pioneering work. It was slightly slower and less agile than its German rival. However, the Meteor's role and context defined its success. It was never intended to duel with German jets over Europe. Its primary and highly successful mission was the defensive one of intercepting V-1 flying bombs, or doodlebugs, terrorizing London. The Meteor's speed and robust construction made it perfect for this. Pilots could chase down the V-1s and, to conserve ammunition and avoid being caught in the blast, use their wingtips to destabilize and tip over the pilotless bombs. This was the first operational victory of Allied jet aircraft. The Meteor was shielded from the fiercest air battles, nurtured by an intact industrial base, and served as an invaluable testbed for the RAF's transition into the jet age. Its reliability and steady development trajectory, leading to more powerful models like the Meteor F-8, made it the cornerstone of Britain's post-war air defense and a successful export, unlike the dead-end Me-262. United States. The industrial juggernaut awakens. The United States entered the jet race with significant advantages: access to British Whittle technology through the Tizard mission in 1940, and the world's most formidable and untouched industrial base. Its first effort, the Bell P-59 Aerocomet, was a disappointment. Underpowered by General Electric IA engines based on the Whittle design, its performance was inferior to top-line piston fighters, and it was wisely kept from combat, serving as a training and test vehicle. America's true World War II jet legacy was the Lockheed P-80 Shooting Star. Designed by the brilliant Kelly Johnson and his Skunk Works team in a breathtaking 143 days in 1943, the P-80 was a generation ahead of the P-59. With its clean, straight-winged lines and a de Havilland H-1B Goblin engine, later the Allison J-33, it was a capable and modern design. A small number reached Italy in early 1945, but the war ended before they saw combat. The P-80's significance was post-war. It was the direct ancestor of the F-80 Shooting Star, America's first operational jet fighter, which would see extensive service in the Korean War. The P-80 program demonstrated the awesome ability of American industry to rapidly absorb new technology and mass-produce it with high quality, a capability that would define the Cold War air race. Japan, the last tragic gasp. Japan's jet efforts underscore the technology as a weapon of absolute last resort. Crippled by a catastrophic shortage of strategic materials, advanced alloys, and skilled engineers by 1944, Japanese programs were acts of sheer willpower. The Nakajima Kikka, a crude, smaller copy of the Me-262, using drawings from a German submarine delivery, managed only 2 brief test flights. The Mitsubishi J-8M, a copy of the Me-163 rocket interceptor, faced even greater hurdles, with fuel so poor it had to be mixed with pine root sap.
These projects were not viable weapons. They were symbols of a nation pushed beyond its industrial and scientific limits, attempting a technological Hail Mary that was, by 1945, utterly impossible. Part 3. In the Crucible of Combat. Tactical Shock, Tactical Adaptation. The operational debut of the Me-262 delivered a profound psychological and tactical shock to the Allied air forces. For bomber crews, the experience was terrifying. The carefully choreographed defensive box formations of B-17s and B-24s, with their interlocking 50-caliber machine gun fire, were calibrated for attacks by Focke-Wulf FW-119s and Messerschmitt Bf-109s, with closing speeds of a few hundred miles per hour. The Me-262 changed the calculus entirely. It could approach from the rear at 550 miles per hour, deliver a devastating burst of 30mm fire from outside the effective range of the bomber's guns, and be gone before the gunners could properly track it. The standard escort fighter tactic, dropping external fuel tanks and diving to intercept, was often futile. A diving P-51 could perhaps catch an Me-262 in a shallow dive, but in level flight or a climb, the jet simply vanished. Luftwaffe pilots developed specific tactics to leverage their overwhelming speed advantage. The standard interception was the rota, or pair attack. Two Me-262s would approach a bomber stream from the rear at high altitude, then make a shallow diving pass to build even more speed. They would level out behind the bombers, fire a brief, calculated burst aimed at engines or fuel tanks, and then, crucially, continue straight through the formation without turning, using their immense velocity to escape the escort fighters inevitably vectored toward them. Turning, they knew, would bleed speed and make them vulnerable. Aces like Oberfeldwebel Kurt Welter, who claimed over 20 kills in the Me-262, many at night in a radar-equipped variant, and Major Walter Novotny became masters of this brutal hit-and-run style of warfare. Yet the Me-262's vulnerabilities were glaring, and the Allies adapted with remarkable speed. The jet's Achilles' heels were its takeoff and landing phases. With engines slow to spool up and the aircraft heavy with fuel, it was painfully vulnerable for minutes at the beginning and end of each mission. Allied fighter groups, particularly the long-range P-51 Mustangs, began implementing jet strafing patrols. They would loiter at high altitude near known Me-262 bases like Lechfeld and Achmar, waiting for the distinct dark trails of the jets taking off, or the telltale sight of them lowering their landing gear. A diving attack on a landing Me-262, its pilot focused on touchdown and low on fuel and speed, was often fatal. This tactic, pioneered by pilots like Colonel Hub Zemke's 479th Fighter Group, proved highly effective, destroying many jets on the ground and in these vulnerable moments. Furthermore, the Allied strategic bombing campaign targeted the jet ecosystem itself. Raids on synthetic oil plants crippled fuel production. Attacks on transportation networks made it impossible to move engines and subassemblies between factories. The jets were not just starved of fuel, they were starved of the very means to be built and sustained. This highlighted the central lesson: a revolutionary weapon system cannot operate in a vacuum. Its effectiveness is contingent on a vast, vulnerable support network of industry, logistics, and training, all of which Germany was systematically losing.
The strategic paradox: technical triumph, strategic failure. This leads to the central haunting paradox of the German jet program. The nation that fielded the most advanced, operational jet fighters derived almost no strategic advantage from them. The reasons constitute a masterclass in how technological brilliance, when decoupled from industrial depth, strategic wisdom, and material reality, becomes an expensive irrelevance. The dictator's folly. Hitler's personal interference in the Me-262 program remains one of the most cited examples of catastrophic micromanagement in military history. His obsession with an offensive blitz bomber to punish the Allied invasion forces was a fundamental misreading of Germany's strategic crisis in 1944. What was needed was not a pinprick strike aircraft, but a mass-produced defensive interceptor to blunt the Allied strategic bombing campaign that was eviscerating German industry. The months lost to the blitz bomber conversion effort were irrecoverable. By the time the pure fighter variant entered service, Allied air superiority was total and overwhelming. Industrial collapse. The Allied combined bomber offensive achieved its ultimate goal, the systematic dismantling of the German war economy. The attacks on ball-bearing plants, airframe factories, and most critically, the synthetic fuel infrastructure, Operation Crossbow and the oil campaign, were terminal for the jet program. Engineers at Junkers and BMW, the other major jet engine producer, were forced to constantly redesign engines to use substitute materials. Final assembly lines were dispersed into forests and tunnels, a process that crippled efficiency and quality control. The famous Volksjäger, People's Fighter program, which produced the Heinkel 162 Salamander, a cheap wooden jet intended to be flown by Hitler Youth, was a final grotesque testament to this collapse, prioritizing desperate numbers over any semblance of quality or pilot safety. The human dimension eroded. The Luftwaffe of 1944 was a ghost of its former self. The relentless air war had consumed its experienced pilot corps. Veteran aces transferred to jets had to unlearn the turning dogfight and master the new energy fighting tactics, but many were killed in accidents or combat before they could fully adapt. The training pipeline for new jet pilots was virtually non-existent. Young men were thrown into the complex, temperamental Me-262 with only a handful of hours in propeller aircraft. The result was a horrific attrition rate from non-combat causes. The weapon was only as good as its operator, and Germany had run out of operators. The overwhelming Allied system. The Allied response was not merely tactical adaptation, but the application of an intact and superior military-industrial system. The US and UK could produce tens of thousands of high-quality piston-engined fighters, train vast numbers of pilots in safe environments, and deploy them with secure logistics. Against this tidal wave, even a squadron of wonder weapons could only achieve local temporary successes. Every Me-262 shot down represented a permanent loss. Every P-51 lost could be replaced tenfold. In stark contrast, the Allied approach to jets was characterized by strategic patience and integration. The Meteor was deployed in a specific, winnable role. The P-80 was rushed to the front but held back from combat, its value recognized as a platform for future development rather than a stopgap solution. The Allies could afford to treat their first-generation jets as stepping stones because they were winning the war with conventional means. This long-view perspective was a luxury Germany did not have, and it proved to be the decisive factor in determining which nations would carry jet technology forward into the next era. Part 5. The True Victory. The Jets as the First Prizes of the Cold War. The most significant and lasting impact of WWII jet fighters was not registered on the battlefields of Europe, but in the frantic, shadowy competition that began even before the guns fell silent. The struggle to capture the scientific and technological spoils of the Third Reich. The jet engine and its associated aerodynamics became the first great contested prizes of the Cold War, directly shaping the military balance for the next half-century. The Great Scramble, Operations Paperclip, Aviation, and Backfire. In the final months of the war, Allied intelligence teams like the U.S. Alsos mission and the British Fiat teams shifted from hunting atomic scientists to targeting aerospace experts.
The American Operation Paperclip saw teams of technical specialists, often operating ahead of frontline troops, swoop into factories and research facilities to seize documents, hardware, and personnel. They captured half-completed Me-262s, boxes of technical drawings for advanced swept-wing designs, and most importantly, the engineers themselves. Key figures like Werner von Braun for rockets and Alexander Lipschitz for delta-wing design were brought to America. The Me-262's chief designer, Kurt Tank, evaded capture by the Soviets and eventually made his way to Argentina and later India, where he continued designing aircraft. The Soviets launched their own, even more massive counterpart, Operation Aviation. In a single, meticulously planned night in October 1946, the Soviet NKVD troops rounded up thousands of German scientists, engineers, and their families from the Soviet occupation zone and forcibly relocated them to the USSR. They also dismantled entire factories, shipping them east by rail. For the Soviets, who had made less progress in advanced aerodynamics and jet propulsion, this bounty was priceless. It allowed them to bootstrap a world-class aerospace industry virtually overnight, forging the Cold War arsenal. The harvested German technology was immediately put to work, defining the first generation of Cold War jets.
The Soviet leap. The Soviets directly reverse-engineered the Jumo 004 engine as the RD-10 and the Me-262 airframe to create the Yakovlev Yak-15 and Mikoyan Gurevich MiG-9. These were interim steps. More crucially, they acquired data on swept-wing research from German wind tunnels. Applied by brilliant Soviet designers like Artem Mikoyan, this knowledge led directly to the MiG-15, a swept-wing high-altitude interceptor with a powerful copied British Nene engine. When it appeared over Korea in 1950, it shocked the West with its performance, proving that the technology transfer had been devastatingly successful. The American evolution. While the U.S. had its own advanced programs, the captured German data validated and accelerated them. North American Aviation used the swept-wing research to modify the design of its straight-wing XP-86, resulting in the legendary F-86 Sabre, the MiG-15's great rival over the Yalu River. The engine technology informed the development of more powerful American turbojets. The P-80 evolved into the F-80 and then into the T-33 trainer, the most produced jet trainer in history. The European Foundation. In Britain, the Meteor continued to evolve. In France, captured German engineers and designs helped jumpstart the indigenous jet industry, leading to aircraft like the SO-6000 Triton and later the Mystère series. The jets of World War II became the seeds from which the post-war aerospace industries of Europe grew, tying them technologically to the superpower blocks while retaining strands of independent capability. The geopolitical implications were profound. The jet engine became the cornerstone of the new bipolar world order. Strategic power was now measured in terms of jet-powered bomber ranges, leading to the B-47 Stratojet and Tu-16 Badger, jet interceptor response times, and the emerging reality of jet-powered nuclear delivery. The technological head start gifted by the German spoils helped ensure that the Cold War standoff was between two powers capable of global jet-age warfare from its very inception. The Me-262's legacy, therefore, was not saving the Reich, but in helping to create the balanced, terrifying stalemate that defined the second half of the 20th century.